Okay, so last video we plotted our data. We realized that this line of best fit is linear and it doesn't work with our data. So we need to figure out what the relationship is for our data. First thing I'm going to do is select my chart, and I'm actually going to make it smaller just so that it can get out of the way a little bit, because we are going to be doing another chart right beneath this. So what I'm going to do is I'm going to say equals. Again, I'm going to go up here and I'm going to select the height, hit return, and really what I'm doing is just recreating the height down here so that I can easily plot the next round of data that we're doing. Alright, so filled that down a little bit. Next, what I'm going to do is I'm trying to figure out what the relationship is between height and speed. Now, maybe it's supposed to be height and speed squared are proportional. That would be a quadratic relation. Or maybe it's supposed to be height is proportional to the square root of speed, in which case we could figure that out. So in order to process our data, we're going to try and linearize it, meaning we're trying to get a relationship that is linear between our independent variable and whatever our modified or linearized dependent variable is. So instead, what I'm going to do down here is I'm going to try speed squared first. So I'll type in speed squared to remind myself. I'm not going to put the units simply because it's going to get a little confusing, but the units would literally be meters per second, all in parentheses, squared, or meters squared per second squared. And what I'm going to do is I'm going to hit equals. I'm going to select my speed value. That's why I'm leaving it up there. And then I'm simply just going to square it. I'll hit enter. And then I'm going to fill this formula down. Next, I'm going to graph this, so I'll highlight it, insert charts. I'm going to go to scatter plots, and I'm going to go ahead and insert it. If you finally figure out what this is, then you'll go ahead and change the chart title and that sort of stuff. Actually, right now, I'll leave it how it is. Last but not least, I'm going to go to customize, and then down here to linear, and try and fit a linear line of best fit. And I'll hit insert, and we'll get a new chart over here. I'm going to shrink this down so it's a little easier to see. Alright, so we can see that that actually ends up fitting pretty well. We could actually do this with error bars in Excel and see that it would fit this through. But what this means is that our height is actually not proportional to speed, but speed squared. Which means that if we were looking at a formula, it would be something like height equals, in this case, some sort of speed squared times some sort of value. So it might be some other value. So it's proportional, not equal in this case. If that didn't work, let's say if instead of speed squared it was the square root of speed, I might up here say to the 0.5 power, and then down here I would change all of my data to be to the 0.5. And then I would fill down and see if that fit. In this case, that doesn't fit. It makes it worse. So you do kind of a guess and check to figure out which relationship between height and the other variable works best in order to linearize your data, to figure out what the actual proportional relationship is. We'll do a better explanation of why we're doing this in class, but for now this is basically just to teach you the skill of how to do it. Instead of transforming your y data, you could alternatively transform your x data. So I could say speed, and then I could have this equal to simply just the value up there. So the B20, fill that down. So those are all the same speeds that I had above, just rounded off a little bit. And instead, if I wanted my height to be squared, I could do my height squared. So in this case, I might have to re-enter height slash cm, but then for this value, say instead of b, I'll do b squared. And fill that down, and we could see if that was proportional. Maybe it would be that the height was proportional to the speed, or height squared was proportional to the speed. In this case, this was height squared. We can see that that doesn't work, so instead I might try to do height to the 0.5 power, or in other words, the square root. I would change my formula to b to the 0.5, then I would fill that down and see if that works. In this case, we can see that changing height to the 0.5 has the same effect of changing speed to the squared. It's because it's kind of opposites since they're on opposite sides of the equation. What it does do though is it changes the spacing between some of the data. That's fine, but it does have kind of an effect on where your data lies within the graph. So I often will prefer to change the y data rather than the x data just to keep the spacing horizontally about the same and be able to focus just on what's happening on the y-axis. That's it for how to linearize your data. And that pretty much sums up how to do most of the processing. Beyond this point, you're going to have to go into Excel in order to use the error bars function. One day, Google Sheets might have it, but just not today.